Hi students, in this video we are going to discuss problems related to relation and function chapter. The question is, let T be the set of all triangles in a plane with or a relation in set T given by the R is E contains set of ordered pairs T1, T2 such that T1 is congruent to T2. Show that or the relation is an equivalence relation. We know that a relation can be called as an equivalence relation if it is reflexive, symmetric and transitive. First we will see about reflexive. Reflexive means in the set of ordered pair T1, T1 exists. It means that T1 is congruent to T1. That is, T1 is congruent to itself. The statement is, as you know, T1 is congruent to itself. We know that each triangle is congruent to itself. Hence, it has the property of reflexive. And then we have to check the property of symmetric. In the property of symmetric, what we do is, in case if we take the ordered pair T1, T2, then as per this relation it means that T1 is congruent to T2, and in order to check the symmetric relation, what we do is we interchange the place of T1 and T2 whether it satisfies the condition or not. So when we interchange T2 to the place of T1 and T1 to the place of T2, what happens is the statement becomes T2 is congruent to T1. This statement comes. We need to check whether the statement is right or wrong. We know that if T1 is congruent to T2 means definitely T2 is also congruent to T1. Hence we can say that this relation has the relation is congruent to has symmetric property, and then we need to check the transitive property. Transitive property is if we consider three triangles T1, T2 and T3 and they are related such a way that T1 is congruent to T2 and T2 is congruent to T3 means we need to check whether T1 is congruent to T3. Of course, T1 is congruent to T3. This is the explanation that we have seen till now. Since this relation R has symmetric, transitive and reflexive, symmetric, transitive property, we can say that R is an equivalence relation. I hope you can understand this question. Now we move on to the next question. The next question is, let A be the set of all rectangles drawn in a plane. So A is a set which contains all the rectangles that can be drawn in a particular plane. Now we need to prove that the relation statement is have equal perimeter on A is an equivalence relation. So the each triangle the set A contains set of all rectangles, and there is a relation R which contains the rectangles which have equal perimeters. So we need to check whether it is reflexive, symmetric and transitive. We define this R is equal to R1, R2. R1 and R2 are rectangles. They have equal perimeters. Only this type of, only when they have equal perimeter, they can be the part of this set R. Right? We need to check reflexive property. In reflexive property, we must have R1, R1. Hence, we can say that we have to check this equal to perimeter. We know that each perimeter, the R1 has perimeter 5 means definitely it itself also the same rectangle also has the same perimeter. Hence, it has reflexive property. Since R1 and R1 have equal perimeter is true, where R1 belongs to set A, R1, R1 belongs to this set R, hence R is reflexive. And we move on to the next property, that is symmetric. In symmetric, if we take this ordered pair R1, R2 and R1 or R2 have equal perimeter means, as in order to check the symmetric property, we will interchange R1 and R2. So we get ordered pair R2, R1. When we have the ordered pair R2, R1, it means that R2 have equal perimeter as R1. Yes, of course, both of them will have equal perimeter only. Now you just observe symmetric concept. R1 and R2 have R1, R2 belongs to R means where R1 comma R2 belongs to set A. R1 and R2 have equal perimeter, and then which implies that they are interchanging. R1 and R2 have equal perimeter, and R2 comma R1 also belongs to the same set R. Hence it has symmetric property. Now we need to check transitive. Let R1 comma R2 belongs to the set R, and R2 comma R3, the set of ordered pair, also belongs to set R, where R1, R2, R3 belongs to the initial set A. Now we know that R1 has equal perimeter as R2 and R2 has equal perimeter R3. Now we need to check whether the ordered pair R1 comma R3 belongs to this set or not. If you look at this R1, as per this relation equal perimeter, definitely R1 has equal perimeter as R3. Hence R1 comma the ordered pair R1 comma R3 also the part of set R. Hence it has all the property reflexive, symmetric and transitive. Hence we can say that R is an equivalence relation. I hope you understand this problem. Now we move on to the next problem. Consider the non-empty set consisting of children in a family, and a relation are defined as A related to B. If A is the brother of B, determine whether R is reflexive, symmetric and transitive. Students, let A is a set which contains set of all children in a family, and the set R contains the set of ordered pairs which has the property of A is the brother of B, where A comma B belongs to set A. Now we need to check whether it has reflexive, symmetric and transitive. The reflexive means in the set of ordered pair A comma A, in this set R we need to check whether the ordered pair A comma A is existing or not. If you observe this, A is when we write A comma A in this set R, it means that A is the brother of A. It is not true because he cannot be the brother of himself. Hence the reflexive property does not exist. That means the ordered pair A comma A does not belong to the set R. Hence the set R does not have this reflexive property. I hope you understand this. And the next one is, let A comma B belongs to R, where A comma B belongs to set A. So we assume that the ordered pair A comma B belongs to this set R. It means that A is the brother of B, right? If it has symmetric property means we will interchange the ordered pair as B comma A, and then it becomes B is the brother of A. And here they say that B comma A belongs to R. Sometimes the relation may not exist, but here they say that it is symmetric. Actually it is wrong. Next one is, because B may be the girl, so A is the brother of B means B can be the girl, so we cannot say B is the brother of A. It is wrong, so it does not have the symmetric property. And the next one is, let A comma B belongs to R and B comma C belongs to R, where A comma B comma C belongs to A means we know that as if this ordered pair A comma B exists in this set R means A is the brother of B, and the ordered pair B comma C belongs to R means B is the brother of C. Hence we can say that A is the brother of C. As per this statement, B becomes the male because A is the brother of B. B can be male or female, but here B comma C exists in this relation. It means that B must be a boy. Then only we can say that B comma the ordered pair B comma C belongs to R. If these two exist means then only we will go for transitive. If this does not exist means we can say that transitive, the situation does not arise. But they say that in the option A comma B belongs to this set R and B comma C belongs to this set R as well. So definitely B must be male. So we can say that A is the brother of C. If you look at this symmetric property based on this transitive property, actually after going for reflexive, in case if we go for transitive and then if we move to symmetric, based on this concept we can say B is the brother. At that point we can say B is the brother of A, then we can say R is symmetric. So you must, when you write it in the examination, first you must write reflexive, then transitive, then based on the transitive property we can say it is a, so it has symmetric property. So we can say that it is reflexive, it has all the it is not reflexive, symmetric, and it is transitive. I hope you can understand this problem. With this problem I am completing this video because time is going up. In the next video we will continue our discussion. Thank you students, thanks for your cooperation.